We are going to learn about units and how to convert one unit to another.
Which unit? Our unit.
What are units? So I can give you some examples. Let's say you're measuring the mass of something, like how much do you weigh? You go on a scale and you record your mass either in pounds, kilograms, or if it's a small object you're measuring the mass of, you will measure it in grams or ounces. So these are units of mass. Basically, unit means the meaning of that measurement. Like you mention a value, a number, like 20, and then 20 what? 20 grams, 20 kilograms. Or for example, for time, 20 seconds, 20 hours, 20 minutes. What are we talking about? So the meaning behind that, or the meaning associated with that number, with that value, that's the unit of it. Or sometimes we call it dimension too. So either dimension or unit of a number. We can express it for mass, for time, for length, meter, kilometers, miles. All these are, and many more, are the unit of length. And we can have it for temperature, expressed as degree C, centigrade, degree Fahrenheit, or Kelvin. So these are all units. Now, in these units, you notice sometimes you see something is similar about some of them. For example, units of length, pay attention to this one. I said meters, which we show it with just M, or kilometers, which again, meters is repeated, but we have a prefix here, K, kilometer. Or you must have heard of centimeters, cm. Again, meters is repeated, and then you have a prefix, centi. What does that mean? What is that prefix? It has a meaning associated with it, and we're going to learn about it. Same thing goes here. We have grams, and then kilograms. The kilo, the prefix kilo, which is shared between this one. So it looks like we can have some prefixes before every unit. Now let's see, what do they mean? So here I'm going to list all the prefixes that you're expected to know when you pass through high school. So I'm going to start from the small ones here on the left. How do we read them? What's their symbol and what's their meaning? So starting with deci. The symbol of it is just D, and the meaning of it is times 10 to the power of minus 1. That's the meaning associated with deci. So what does that mean? That means if I say decimeter, dm, like instead of centimeter, I say decimeter. What does that mean? That means 10 to the power of negative 1 meters, or 0.1 meters, right? 1 decimeter equals 10 to the power of negative 1 meter. In other words, 0.1 meters. That's deci. That's the meaning of deci. Let's see the next one. Centi. The symbol of it is C, lowercase c, and the meaning is 10 to the power of negative 2. So when I say 2 centimeter, that equals to 2 times 10 to the power of negative 2 meters. In other words, 0.02 meters. That C is as if it's a code that the meaning of it we can associate it with times 10 to the power of negative 2. So we decodify these prefixes. You can think of these prefixes as a code, and we decipher them. So centi. Now we're getting smaller and smaller, right? 10 to the negative 1, deci. 10 to the negative 2, centi. Next, milli. Lowercase m is the symbol, and the meaning is 10 to the power of negative 3. So you must have heard of milliliters or millimeters. Like 1 milliliter equals 10 to the negative 3 liters. Similarly, 1 or 3 millimeters equals 3 times 10 to the power of negative 3 meters. So that's milli. And these names come from Greek. They come from Greek language, and usually they're associated with that power of 10. Okay, micro. Now here the symbol is in Greek letter, is mu. like this. So imagine an M would be like this. Mu is like you touch this side of an M like this and make this leg shorter than this leg and attach this side to this side, that you create a mu and make this side curvy. Okay, so that's microscope. You must have heard of microscopes. So micro is 10 to the power of -6. Now we're jumping from -3 to -6, 3 orders of magnitude smaller. So microscope is something that you can see things that are of the level of micrometer. So 1 micrometer is 10 to the -6 meters. So objects of this size, which are usually like microbes, microorganisms, you can see them with a microscope. Now next, let's get smaller. Nano, lowercase n is the symbol, and the meaning is times 10 to the power of -9. You must have heard of, or maybe you have heard of, nanomaterials. So those are materials that are of the size of nanometers. Nanometer, like 1 nanometer equals to 10 to the -9 meters. That's like several times thinner than your hair, than a single hair. Let's get even smaller. Pico, lowercase p, the meaning 10 to the power of -12. Excellent. So those are the ones that you deal with mostly in high school and college. And even to be honest, I went through PhD and I never needed any other prefix other than these that I'm going to list today. So they're pretty useful all throughout your journey of education. Now we're going to, on the right hand side, we're going to talk about prefixes that are for like larger quantities. They meaning actually when you decode them, that makes your number even bigger. So starting again from the smallest to the biggest. So deca, symbol is DA, the first letter and the last letter, deca, meaning 10 to the power of 1. Next, hecto, the symbol is just lowercase h, 10 to the power of 2 is the meaning. Kilo, remember kilo from kilometers? That's 10 to the power of 3. So if I say kilometer, that is like 2 kilometers, that's 10 to the power of, so 2 times 10 to the power of 3 meters. In other words, 2,000 meters. That is kilometer. Or kilogram. 1 kilogram is 1,000 gram. Nice. Let's get even bigger. Mega. This you must have heard of in when you deal with files, like digital files, 1 megabyte, 2 megabytes. So mega, it has uppercase M. That's the symbol. So here, we are case sensitive here. We have lowercase m, that's milli. We have uppercase M, that's mega. And I'm going to put it here at the center. And the meaning of it is 10 to the power of 6. You can think of as a million is the same as a million. If you have 1 mega dollars, by the way, dollars is the unit of money for many countries. $1 million, 1 mega dollars, that's like $1 million, 10 to the power of $6. So that the prefix M, think of it like million. Let's get even bigger. Giga, this again is useful when it comes to the size of the files on computer. Gigabyte, uppercase G, 10 to the power of 9. That's the meaning. So if I say I have 2 giga dollars, I wish that for all of you, that equals 2 times 10 to the power of 9 dollars, or in other words, $2 billion. That's the meaning of this prefix, giga. Let's get one size bigger.
Here's an even bigger one.
Tera, terabyte. Like when you buy a hard disk, they are sized based on their size, how much files you can put on them. So terabytes are a usual prefix when it comes to the capacity of a hard disk storage. So that's 10 to the power of 12. So 1 terabyte, that's 10 to the power of 12 bytes. Or 1 tera seconds, that's a lot of time. That is 10 to the power of 12 seconds. Or 2 tera seconds, that's 2 times 10 to the power of 12 seconds. So the things to be careful with is, as I said, and I want to emphasize again, the uppercase, lowercase. So you can see here we have a couple of similar things. So one thing is M, uppercase is 10 to the power of 6. Lowercase m is milli, and that's 10 to the power of -3. So we have to be careful with that. Don't mix that up. We have deci, that's 10 to the -1. And we have deca, that's 10 to the power of +1. So dA, you can think of it as dA has 2 letters, so it's bigger, more letters, then that's the big unit, 10 to the power of +1. D alone, that's deci, that's the small, fewer number of letters, just D in the symbol, so that's 10 to the power of -1, just a way to memorize. And then the rest are unique here, so you won't have a big problem with that. So you want to memorize this, and the technique to memorize this is the same technique as to how to memorize the multiplications of numbers, the table of multiplication of common numbers. So if you write this down a couple of times, that makes it much easier to memorize. You can just list this from scratch, try to do it from your head. But if you don't remember, look on your notes, again, try to do it from your head. And list this, write it down a couple of times. When we write things down, that's easy. That's one of the good techniques to memorize things. Just write them down. Okay, let's see a couple of examples. How do we convert these into each other? What do I mean? How do I, for example, if I say 1 millimeter is equivalent to how much kilometers? Let's say I want to have that unit conversion. How do we do that? So let's see together. Let's say 2 millimeters equals to how many kilometers? So I'm going to teach you a technique that makes it very, very easy and very unlikely to make a mistake. First of all, you want to decodify those prefixes. So I know here I have a unit of meters. That's my unit, meters. And then milli here is the prefix and kilo is the prefix here. So replace those prefixes with what they mean. Okay, on the left hand side, 2 millimeters. That means 2. I'm going to decodify milli. I know milli means 10 to the -3. So 2 times 10 to the -3 meters, I have on the left hand side, equals question mark. What is kilo? That's times 10 to the power of 3, +3. So question mark multiplied by 10 to the power of 3 meters on the right hand side. Okay, now it looks like a linear equation that we're going to solve. So I'm going to put a link to how to solve linear equations on the top right. It's going to pop out if you're not watching on a TV. And also I put a link on the description. But basically this is a linear equation and we're trying to solve for the question mark here. If you find the question mark, you know the answer. So I'm going to, first of all, divide both sides by m to get rid of that m in that equation. So the m will just cancel from both sides if you do that division, and you will get 2 times 10 to the power of -3 equals question mark. Of course, you can replace question mark with an x, which we will do after this example. So this first one I just want to show you. Question mark, you can even have a question mark and get away with it. Now we want to isolate that question mark so we can see through its value. In the next step, right now question mark is multiplied by 10 to the 3. So I'm going to do the reverse. I'm going to divide it by 10 to the 3. So dividing both sides of the equation by 10 to the 3. And whatever you do to the one side of the equation, you want to do that to the other side of the equation so that the equation is balanced, the equation is maintained. So dividing, that means 2 times 10 to the -3 divided by 10 to the 3 equals, and if I divide the right hand side by 10 to the 3, the 10 to the 3 is going to cancel. So the question mark equals this fraction. Now let's do this. Let's simplify this. So 2 times 10 to the negative 3 divided by 10 to the 3. We know that, just a review, we know if, for example, I have 1 over x to the power of a, I can bring that x to the top and write it as x to the power of negative a. This is an algebraic rule about exponents. So I'm going to do that, follow that for the 10 here. Bring it up to the denominator, to the numerator. So once again, I'm going to write question mark equals 2 times 10 to the negative 3. And since I'm going to shift this to the numerator, to the top from the denominator, I have to flip the sign of the exponent. So multiply it by 10 to the power of negative 3. Excellent. Now let's simplify this further. I have 2 times 10 to the negative 3 times 10 to the negative 3. You can see that the bases here in this multiplication, they both have the same base, 10. So I'm going to use this algebraic rule. When I have x to the power of a times x to the power of b, the bases are the same. I can write the answer as put one base, x, and then add up the exponents, a plus b. That's it. Just a review. So then that's 2 times 10 to the power of, add up the exponents, minus 3 minus 3. What is minus 3 minus 3? 2 minus 3 basically. 2 times minus 3. So that's minus 6. 2 times 10 to the negative 6. That's our answer. What does that mean? That means 2 millimeters is equivalent to 2 times 10 to the power of negative 6 kilometers. Let's see another one. Let's say 7 giga seconds is equivalent to how many pico seconds? So we're going from a very large prefix, right? Again, same process. Step 1, replace those prefixes with what do they mean. So I said 7 times 10 to the power. What was giga? We know mega was like million, 10 to the 6. Giga is like billion. So 10 to the power of 9 seconds equals question mark. What is pico? That's times 10 to the power of. So nano was 10 to the negative 9. Pico is negative 12 seconds. Now dividing both sides by the seconds, so get rid of that s. Now instead of question mark, let's just replace that with an x. Let's be more posh here.
I wish I wasn't so posh.
So x instead of question mark, the unknown, we want to know the value of. So x times 10 to the negative 12 I have on the right hand side, and on the left hand side 7 times 10 to the 9. Okay, let's solve for x, meaning let's isolate x on one side. So x, I'm going to next divide both sides by 10 to the negative 12 to isolate x. So x will be alone on the right hand side, and here I will have 7 times 10 to the 9 divided by 10 to the negative 12. Alright, so x equals, same rule, I'm going to bring this guy to the top from the denominator, I'm bringing it to the numerator. So I flip the sign. Instead of negative 12, I can write 7 times 10 to the 9 times 10 to the power of negative 12. I flip the sign and bring it up. So negative 12, that's just positive 12. And here I have 10 to the 9, 10 times 10 to the 12. The bases are the same. I add up the exponents. So that's 7 times 10 to the power of 9 plus 12. Or x equals 7 times 10 to the power of 9 plus 12. That's 21. That's it. 7 gigaseconds equals 7 times 10 to the power of 21 picoseconds. Let's see another one. 3 microgram is equivalent to how many hectogram? All right. Same thing. First, decodifying. Step 1, decodifying the prefixes. Micro, that's 10 to the power of what? Micro, that's microscope. That's negative 6 3 times 10 to the negative 6 gram equals how much hectogram? What was hecto? That's 10 to the power of 2 grams. Excellent. Let's just cancel the g, divide both sides by a g, so we don't need to keep writing that anymore. I'm going to replace the question mark with a x just to make it easier. I'm used to write down x. You can carry on with the question mark as we did in the first example. Now dividing both sides by 10 to the power of 2. You isolate x on one side, so you have 3 times 10 to the power of negative 6 over 10 to the power of 2. Alright, so same story. X equals 3 times 10 to the negative 6. I'm bringing 10 to the positive 2 to the top, from the bottom to the top, so I have to flip its sign. So that's 10 to the negative 2. Now I do the multiplication. The bases are the same. 10 to the negative 6 times 10 to the negative 2. That's 10 to the negative 6 minus 2. So that's x equals 3 times 10 to the negative 8. So 3 microgram equals 3 times 10 to the negative 8 hectogram. Just like that. And it will be the same with any other unit conversion. Alright, hope you enjoyed it. Let me know if you have any questions.